So these directions, I'm just gonna put a little side note here for you. Okay, so unless the directions say evaluate or round, it's implied with radicals that you just keep everything in simplest radical form. And the directions should say, simplest at radical form, but I just wanted to highlight for you that the word evaluate typically means go ahead, get a calculator, go to a decimal, and of course rounding. Okay, so number one is that product property where we add exponents. So that would be 4/5 added to 6/5, which would make this 10/5. So ultimately, 1 should go all the way to x squared. When you multiply the same base, you add exponent. Taylor, do you have an earbud in? You got earbuds in? Okay, I get it. All right. And number 2, power of a power. Because like number 1, you see that base x twice. This isn't the case in number 2. It's an exponent, then right again, another exponent on the outside of those parentheses. So those will get multiplied. I'm going to go ahead and zoom focus here. So go over the answers. So this would be 1 base y, 2/3 times 3/4. Multiply the tops and get 6. Multiply the bottoms and get 12. And so my final answer, y to the 1/2. You got that one right, you guys? Did you multiply? Or did you add? You don't do common denominator. When you multiply, you don't have to. But when you add, you do. So multiplying just means top times top, bottom times bottom. Reduce it 1/2. Now this is the same thing as the square root of y. So that would be equivalent, but this is how we want our answer in. All right, now at 3 and 4, we have a quotient property. We got the top and bottom. So we'll subtract there. And erase all this. Focus on 3. I always like to write in the invisible one. Gosh, this problem looks familiar. I feel like I've done this exact problem with a different letter. Okay, this would be P. 1 minus 1/3. Subtract those exponents top to bottom. So with subtraction, you need a common denominator. So 1 is the same as 3/3. Common denominator. So this ends up being P to the 2/3 power. How do we do on that one? You got that one right, Luke? Okay. Just write in for a second period. All right, number 4. Making things a little bit more complicated. Subtraction again. 1/2 minus 1/3. That's when you need your common denominator. When you're adding or subtracting, you need the same denominator. Natalie, did you do this one? Yeah. And did you get a common denominator? Yeah. What was your denominator? 6. All right, they'll both be denominator 6. Okay, so to turn the first fraction to 6, I have to multiply the top and bottom by 3. 3/6. That's good. Multiply the second one by 2. And now we can subtract. And our final answer is x to the 1/6. Any questions on 3 or 4 that fraction works? All right, 5 and 6 really changes topic, and that's just chapter 5, section 2 has like 5 different types of problems. Just a lot of variation. We got exponents, we got radicals. In a minute, we're going to look at fractions with radicals. So there's just like a lot of topics all tied into one, a lot of different skills we're practicing. So this is all the same section. Rational exponents, radicals, same concept. Okay, so for number 6, I know I can't actually. I always have you guys tried this in your calculator. Can you put this in a calculator and get anything besides the decimal out? Number 6 works. We have to show work, but yeah. Number 5, try to put it in there. See if it simplifies. It doesn't. You can do decimal, but you should still know how to do it. Okay. I think I have an extra for when we get to the problems. We're gonna do a whole bunch of problems on there, so I'll try to do an extra. That looks like it right there. Can you pass that in? Somebody else the other day, I think. Is that volume 1 or volume 2? No, we're supposed to be. What did you do? You have your book? Yeah.
Oh, no, this is volume 1. Say out.
That's good. Yeah, chapter 5. Yes.
Yeah.
What's that? We could. You always want to be thinking about that. Should I look at this as a rational exponent? Should I look at this as a radical? Actually, what I think I'm going to do is I'm going to refer to my list in my mind. I keep saying, think about the list. Go to the list. And people are like, Mrs. Bauman, what list are you talking about? So when I'm doing radicals, I'm always thinking about these lists. And I make them on my paper, I think. So since we're looking at a 6th root, I think about 2 to the 6, 3 to the 6, and 4 to the 6. And I try to look, does that number divide by any of these things? So 2 to the 6, I'm just going to check it out on my calculator. What is it, guys? 64. 2 to the 5th is 32. We see that a lot. 1 is 400. We don't really go to 6 powers a lot, but 2 to 6 is 64. 3 to 6 is a huge number. 729. Okay, so I'm really hoping 128 will divide by 64, does it? So since this is a 6th root and this is 2 to the 6th power, those numbers are related. So I'm going to actually break this up, and I want to rewrite 128 as the 6th root of 64 times the 6th root of 2. This is the same thing. It's equivalent. You can rewrite it as 2 fractions. 64 times 2 is 128, and they're both 6th roots. Now, I know the 6th root of 64 is 2 because of this fact here. So I can go ahead and root that. The other 6th root of 2 is stuck. There's nothing I can do with that. That's some baby old decimal. So this final answer is 2 times the 6th root of 2. And that's called simplest radical form. There's nothing divisible in that radicand that can be rooted. Now I'm going to wait, and I want you guys to work on 6 in case I got ahead of you. We're a little bit more warmed up now. 32. Try to rewrite 32 into numbers that could square root. Looking at perfect squares now. 16 squared. square root, so 32. 36 does. These are kind of dry. Yeah, you just keep going. So yeah, pretty much. Do the 32, rewrite it. Alright, so I know with the square root there's an invisible 2 in here. So I'm thinking about my mental list would be 2 squared, 3 squared, 4 squared, 5 squared. So I'm wondering if 32 will divide by 3, or no, 4, 9, 16, or 25. Divides by 4 also divides by 16. So I'm going to rewrite it using that 16. So 32 is the same thing as the square root of 16 times the square root of 2. And then for the second portion, 16 actually is square root. So I'm going to bring the 3 down, but I'm going to go ahead and square root 16 and turn that into that 4 that it is. The square root of 16 is 4. So I'll keep going here. I'll make this square root of 16 4. So I have 4 times the square root of 2 times 12. That regular 4 and that regular 12 will get multiplied. Those two integers, and then we get 48 square root 2. Final answer. The calculator will actually do that one. It won't do 5, but it'll do that one. But you gotta know how to show work. That is it for bell work. We left off Friday on page 433. So go ahead, open your books to 433. I did evens in class, so I'm assuming everybody has the evens done because I did them all with you. And then you were to do odds on your own. Homework, schmomework. Let's take a look. Yeah. Oh, it depends on. Does it depend on your 6th period today? It would depend on 4th period, I would think. Yeah. We'll have to listen. Let's try not to talk during the announcement. What do I do? Same thing? I don't even know. Oh, was it 5.1? Oh, I can't find my odd answers. I know they're here. 22, 24, 28, 36, 2022, 2022, 24, 28, 26, 2022, 19, 21, 25, 2, 3. Oh, wow.
I tried crack the spoon. What you do? Crack the piss. Come on. I don't know how that. Ain't nothing happening out of that. You gotta cut it off.
All right, here's the answers. Oh, it's so blurry. Unacceptable. How's that? There we go. All right. Of course, you already had the odds. Sorry to stutter. So I'm hoping you already checked your odds, but here they are just in case. I did the evens with y'all, and then the odds are in the back of the book. So, but if there's any that you're like, I don't know how they possibly got 5, you need to ask, and I can go through that work with you.
How much you charge me? What? I have to come after school to like redo it, or can I just like show you when I get there? I'm gonna get my book back.
No, you have to come after school like everybody else.
No, I'm talking about like after school. I was just showing you.
No, you have to redo it. Yeah. Listen, I have 200 students, 50 of them every day tell me they forgot their book. Okay. And if I said, sure, bring it back whenever you feel like it, or bring it back tomorrow, who would ever do their homework on time? Nobody. It's like, I mean, I'd love to just be like, yeah, just come back, show me time, but you know the chaos that ensues when you're trying to organize 200 assignments and people can turn it in whenever they feel like it? So it's not to be unfair, it's actually to be fair and consistent. Students appreciate it, you treat everybody the same way. So if I can be like, yeah, bring it whenever you feel like it, and then I have to tell that to everybody.
Amen.
That's not cool, people don't like that. People want everyone treated the same way.
I'm gonna use my last free assignment pass.
Okay.
Okay.
I did 1 through 7.
Okay, so
What else did I have?
who has a question though about their answer? Wants to go through some work? Anybody? Let's look at. I think number 9 was probably the most difficult question for you guys. So let's take a look at 9. And we're building upon these skills today, so we really want to understand them. Oh wow, look at all the work. Looks so innocent, but all right. The main mistake students make with number 9 is they see the 4 and the 16 and they create the same base of 4. They make 16 4 squared. But because we have the smallest base is 2, it's actually best to try to rewrite all of those as 2 with an exponent. So 16, I'm going to take out, and I'm substitute in 2 to the 4th. 4, I'm going to take out, I'm going to substitute in 2 squared. When everything's the same base, you can start to use all those properties. Until then, you can't. So making the same base is the skill here. Now that 16 is 2 to the 4th, I'll have to multiply power over a power and make that 8 thirds. Multiply here as well, creating 4 thirds. So that'll combine to be 10 thirds over 4 thirds. Subtract. And then the final answer is to be a regular plain 4. It's kind of crazy. What? Any calculator?
No, it shouldn't work.
But you did 2 and 2 times 16. What did you get? 4. How do you get 4 from that? Any calculator. Because you can't multiply these bases if they have this. Oh, you could do this. This I bet is what you did. You could do that. If you show that way, you're looking at.
So when you have the number outside of the parentheses, you only multiply the number inside the parentheses by, you don't multiply by the denominator, you only do the top number.
Oh yeah, that's just for instance this. A better way to show it is if I put this 2 as 2 over 1. And that's 2 times 2. And then there is a number there that I'm multiplying, but it's an invisible 1. And that's what
So it's just top, bottom, bottom.
Yeah, there's invisible 1 there. Other questions? Okay.
I made a mistake. When I multiplied, I did 2 thirds, 4 thirds.
Okay. Do you want me to leave this up here for a minute, or are you good? Alright, good. Here's the rest of the answers. I don't think I showed the answer to 15 and 17 just yet. And here they are. Impossible to read. How helpful. Not impossible to read. And maybe I should just do them. Alright, 15 is 3, 17 is 6, and 19 you didn't have to do. So, any questions on 15 or 17? Even 18, I don't even think we got to. Alright, I just have 2 little notes for you. We're gonna add on to these skills of working with these fractions. 2 little notes, and then we're gonna try 2 more problems that are in this realm of exponents and radicals. Yeah. Cool. Let's take a look. I think what I would do first is make this a great big old fraction. And when you did 486 divided by 2, what'd you get? You can, but if you're gonna do that, actually this is today's lesson. This is 2 to the first in here, and what you would need to create is the fifth root of 2 to the fifth, because you need an index and an exponent to cancel a radical. So I would be multiplying in the fifth root of 2 to the fourth, and not just a 2. Why did you multiply 2? You thought you were rationalizing that? Yeah, so this is today's lesson. So if this was just a square root, yes, I would just do 2. But the higher index, you'll need more than just 1, 2. You'll need to match that. Yeah, you can if this is both fifth roots, it's complicated. I mean, just to graduate, yeah, 4 high school math credits. Yeah. And so now that they're offering high school classes in middle school, there's like this question of, if I have 4 high school credits, do I have to take math? And technically you do. You have to be in a math class every year you're here. But then the rules for a high school diploma, there's like different levels of diplomas, are different than the rules of how do you get into college or NCAA rules and things like that. So just be really careful. Make sure if you want to play a sport that you're very aware of all the different divisions and things like that. 486 divided by 2. Just go ahead and divide that. And then you do the fourth root of 243. I'm sorry, the fifth root. Did you say the answer was 5? 3, yeah. Yeah. Yeah, there is like a guide on the website for all the credits you need. Alright, let's move on. Here's our notes for today. It's just 2 little notes. Then we're gonna work some problems together. So we've already done half of this section. We're on the second half of this section, and the whole theme is this rule that radicals cannot be left in denominators. So we're gonna do different tricks and strategies to clear radicals from denominators. And when you go into when you start doing trigonometry in pre-calculus or in ACE math, you'll start to see fractions, and I hear ACE students tell me this all the time. They're like, where did this denominator come from? How come all of a sudden it's a 3? And that's because these different tricks are coming into play and the work isn't shown. They just take a radical denominator and they rewrite it correctly without really explaining it. So this is kind of background work that you need to know moving forward. There's 2 strategies that we use to clear radicals from denominators. The first one is the conjugate, and the conjugate was a semester 1 vocabulary word. In semester 1, we looked at the complex conjugate with the imaginary I. The complex conjugate was like A plus BI. Its conjugate was A minus BI. The sign in the middle, or the sign with the imaginary part, is opposite. So it's the same expression with an opposite sign. When it comes to radicals, it would be like A plus the square root of B. Its conjugate is A minus the square root of B. Multiplying a fraction by a conjugate will help clear radicals from denominators. The other strategy we'll use is creating perfect radicals that can simplify. And I was just talking about that. On number 15, I was just kind of suggesting. I don't know. I mean, 7 times 4 is 28. But maybe there's like a leeway. The semester's half a credit. 4 years, 1 whole credit. You're pretty close. And then you got like 13, 12, 11. Alright, so, yeah, I don't need to start yet. Oh, wait. For the second strategy, your goal is for the index to match the exponent. So you don't have to write these, but here's some visual examples. If you had the 5th root of x to the 5th, that's just x. The index and the exponent, they are perfect opposites, and they cancel each other out. Like adding 5 and subtracting 5 at the same time doesn't do anything. Or if you have the cube root of 2 to the 3rd, that's just 2. These little guys cancel each other out. If I had the 7th root of 12 to the 7th, I wouldn't touch a calculator. I cancel those 7s out. This is just 12. Okay? So our goal is for that index and that exponent to always match. So here in this example, we have a situation with this radical in the denominator to clear it. We have the cube root of 2 to the 1st. And what we would want, our goal is to create the cube root of 2 to the 3rd. So you have to think, well, how many more 2's do I need? If I have 1, I'm going to need 2 more to create my goal. So I'm going to multiply the cube root of 2 squared to the top and bottom. And that's just creative thinking. You figure out what's going to work. You multiply it in. So the top will be 1 times the cube root of 2 squared is just the cube root of 4. The bottom is the cube root of 2 to the 3rd, which is what I wanted. Add 1, put 2 more in, that creates 3. And so I can cancel. And my final answer would be the cube root of 4 over a clean 2. And mathematicians just highly favor this form of this fraction. They can visualize or picture splitting a number into 2 parts, 2 equal parts, splitting it in half. But this they don't like because the cube root of 2 is like an irrational decimal. It's kind of like pi. This is a decimal that goes on forever. And so they don't like this idea of dividing by something so irrational. They prefer this, dividing by a nice even 2. So this is the form that we're going to try to end in with a good denominator. 1 over the cube root of 2.
Oh, the cube root of 1/2.
No. No, you can't. Any calculator, but, have you ever heard of the unit circle? So on the unit circle, actually, 3, 4, 5 triangles. This is 2x, this is x, this is the square root of it. X, that looks familiar enough. Yeah, like this is your shortest length, this is twice it, and this is, yes, okay. So, when you start to learn sine waves, so understand sine waves, they really, we just embed right triangles inside wavelengths, and then we incorporate these ratios that we know about triangles. And all these ordered pairs, instead of ever square rooting 1/2, it is shown rationalized, and the denominator will be real. So you won't recognize the way data is presented moving forward if you keep relying on that form. It's everything's going to be shown rationalized because that's the way mathematicians have decided they prefer it. So. And they won't even explain how to go from this to this. It just shows up like this. And A's math students always tell me, like, where did this 3 come from, or where did this 2 come from? And I'm like, oh, they rationalized it without even telling you. So it's real. It's a real skill, even though it's equivalent in your calculator. Okay. So let's do it. Are we ready? Okay. We're doing 19 to 42 evens in class, odds for homework. I do have a video to show in the middle somewhere, just to kind of break things up. I know it's block schedule and all that. In fact, I think maybe we'll just do evens and never do the odds. Just work these out. I don't know. We'll see. 19 to 42, I say. Here we go.
The same page.
Same page, same section on the book. We're doing even more skills in the same section. It's like 5 different skills we practice. So I'm doing even. Let me just write this assignment out again. Page 433 to 434. I'm going to do 20 through to 42 even in class. If you're working well and you're going quickly and you're bored, you guys go ahead and do the odds as I go through them. That's fine, but for now, let's just do even. All right, so I'm starting with number 20. You want to write it in simplest form. It doesn't say no decimals, but that's implied. We don't want decimals. So I'm going to head to the 5th root of 288. All these odds. I do see that if I need help, I can refer to example 3. That's nice. Okay. So for my 5th root, I'm going to imagine my mental list of powers of 5. And I do have a calculator, so I can help me with that list. 2 to the 5th is 32. 3 to the 5th is 243. 4 to the 5th, I think, is 1024. So I'm going to go ahead and I'm going to check, does 288 divide by any of those numbers? Okay, 288 divides by 32. So I'm going to rewrite 288 as 32 times 9. I had to check that in my calculator. And then I could split this up if it's helpful. You don't have to, but you can. This is the 5th root of 32 times the 5th root of 9. Alright, the rule is no radicals in denominator. Right now we have the fourth root. This person's out right now, actually. When they come back. The fourth root of 27. So I have to see 27. My whole life I've seen 27 and I always think of 9 times 3 or 3 times 9. That's pretty much what I see when I see 27. But I also, now that we're using radicals, I also want to make sure that I see 27 as 3 to the third. Those are the same. So I'm going to rewrite this as the fourth root of 3 to the third. Now I don't care about the top. The top doesn't have all these special rules that the bottom does. So I'm going to leave the top just like it is and focus on the bottom. Now if I want to get rid of this, I have to set my goal as the fourth root of 3 to the fourth, because when the index and the exponent match, I can cancel them and have a plain old regular number. So how many more 3's do I need to get to my goal? I need just one more. So I'm going to multiply another 3 in. And the rule is, as long as I do it on the top and the bottom, I am really not changing the value. Multiply that in. So the top will be the fourth root of 12. The bottom will now be the fourth root of 3 to the fourth. Because when I multiply the same base, I add exponents. And so this is mission accomplished. I've met my goal. I can cross out those 4's. This is the fourth root of 12 all over 3. And just like Carson was saying, in my calculator, this orange box is the exact same decimal as this black problem they've given. So why does it matter? Well, it only matters because we decided long ago that denominators should be more simple. So this is a simpler denominator. That's what we're going to put into our functions and our equations instead of that first one. They're equivalent. All right, 24. Question? That's really interesting. 24. So 7 and 4 aren't compatible anyway. So I'm just going to split that up. 7 and 4 don't work well together. They don't reduce. 4, I could move forward with 4, but when it comes to radicals, it's best to make numbers as small as possible. So I'm going to rewrite 4 as 2 squared. Smaller base is helpful. So this is the top stays the same. I don't care about the top. But the bottom, I'm going to turn into 2 squared. Because 4 is 2 squared 1 half. So then my goal on this one is to create the exponent and the index. So how many more 2's do I need? I just need one more 2 in there to create my goal. So I'll put one more 2 into the top and bottom. So the top will be the cube root of 14, and the bottom will be the cube root of 2 to the third. So my final answer is the cube root of 14 all over a regular 2. That looks like, I like the one I did. All right, now I'm going to wait and see what you guys can hash out on 26. So think about rewriting 25 as 5 squared. See where you go. How'd it go? How's it going? Oh shit, this 1296 I recognize. You guys probably don't. Yeah, there's something, I think 1296 is actually, I have to check my list of scores. It's 6. So I'm thinking 2 to the 4 is 64, 3 to the 4 is 81, 4 to the 4 is 256, 5 to the 4 is 625. I usually stop there. 6 to the 4 is 1296. And the more exposure you have to these numbers, the more likely you are to recognize that can be rooted. So let's look at it. Okay, 6 to the 4th, 1296. So when I separate the top and bottom, I can actually go ahead and just make the top a 6 because it just happens to be in that list of powers of 6 to the 4th. And then 25 I see as 5 squared because that's how these indexes and exponents work. So this is just 6 over the 4th root of 5 squared. So I'm going to set my goal at the 4th root of 5 to the 4th. So how many more 5s do I need to multiply in the top and bottom? I got to get 2 more 5s in there because I want 4. So I'm going to do my product dot, and I'm going to put 5 squared in the top and bottom. And so this would be 6 times the 4th root of 25 all over the 4th root of 5 to the 4th. And I can cancel those little 4's out. And my final answer, 6 times the 4th root of 25 all over 5. And that is a preferred form. Somehow, this is simpler than that one. Except for debate, I guess. Okay, questions on 26. I think 28 starts a new topic. Yeah? They look different? Yeah. Okay, so these were all the notes I just gave you. These problems were all the second strategy. I did the second strategy. So now we're going to go back to that first strategy, the conjugate. This should be more familiar to you because we practiced the conjugate with the imaginary eye. So jump into 28. Does anybody need me to leave this longer? We good on 28? 28. Okay. All right. Erase all this. I don't know how you guys are fitting this on that paper. I don't even know what the fire is. Okay. Cancel out. So you can see what I'm working on here. Okay, here's 28. Alright, I'm going to get rid of that 5 somehow. I will use the conjugate. So for an expression, use the conjugate. The reason this is called an expression and the ones we just did aren't is the presence of the plus sign. It's like a whole problem there. So conjugate again is opposite sign. So this would be 2 minus the square root of 5. I'll multiply that into the top and into the bottom. In the top you distribute, the bottom you FOIL. First outer inner. so 4, that means I'll do 2 times 2, write down 4. I'll do 2 times the negative square root of 5. That'll be minus 2 square root of 5. I'll do the square root of 5 times positive 2, so that'll give me a plus 2 square root of 5. Square root of 5 times the square root of 5 is the negative square root of 25. And then down here, you simplify. The middle two are opposites that cancel. And the bottom, the middle two cancel. And then this one always square roots. You're always gonna have a perfect square right there. So it's very cool, the power of the conjugate to take a radical and make it a real number or a rational number. So 2 minus the square root of 5 all over negative 1. I'll just divide everything by negative 1. And here's my final answer. Okay, so we have to do 30, 32, 34. So I'm going to start offering some extra credit for coming to the board now. I think these